here it's good. Can I start it? All good?
Yeah, let's go.
Let's go. And we're live. Hello everyone.
All right.
Welcome
Let's
to
make sure.
another tutorial. Let me make sure that we're live, but I'm pretty sure we are because it says live here. So, but to make sure, let me go to the. If anyone can just say hello in the chat, we'll make sure that we are live. Otherwise, I can just go to the link directly and check it out myself. Let's see. There we go. And we're live. Anyone can just say hello.
Good enough.
All good. So Steve,
Okay.
welcome again to another one of these tutorials. So can you just go explain everyone what we're doing today? So we left off the other time we did all our modules, correct? If I'm not wrong.
Yeah, we made a bunch of modules and we were talking about kind of the data that we're going to need to build this thing out. And it was very slow because nothing was pre-coded. So we lost a lot of time in the Vim. So this time I uploaded a bunch of code that's kind of semi-working to GitHub. And that GitHub link can be pasted later after we're done, maybe at the end. So the idea is that now the code is sitting in GitHub. Afonso can go on, just grab the function, boom. But instead of just cloning the repo and running it, we'll go through it one at a time so that the thinking can be understood.
And explain, yeah.
So remember last time we were talking about, how to build a smart contract. We have these two concepts. We have the REPL, and the REPL is sort of the place where the loading of the modules and the transactions take place. So the REPL kind of simulates what would happen with people clicking a front end and then messages being sent via API to maybe smart contract function, and then something happens, whether it's a table or a change of state in the table, or perhaps some function that uses the data to make a new transaction. REPL is just a bunch of transactions. That's the way to think about it. So simple, right? And we kind of figured it out. You just, you have a begin transaction and a commit transaction, and then stuff happens in between.
Exactly.
And we were thinking of, the types of data that we need. We needed a game object. We needed a player object. We needed a actions object where the things are happening, the actions. So it's like layers of the onion, right? So the player is up top, because the players can be in many games, and each game is a little instance. So you're in the next layer of the onion, and then you're in the next layer of the onion, which is the actions in the game. And then accounts kind of sits on the side. And we won't get to accounts today, I don't think, but the other three will definitely probably pretty much I'll finish the whole thing off and actually see some dice throws today. Okay. And it just will give us an idea of how to write, a bunch of functions and consider constructing a game here. So, it's a process, and I'm still learning Pact. Definitely a little frustrated today with some Pact stuff, but also some stuff was lovely with Pact. It's so easy sometimes, and we're going to learn that now. So I guess the first thing, Afonso, to do is, we got to start always at the top layer of the onion. And that, so can you open the REPL again for us?
So
can. Go to your dice game.
Okay, so so CD maybe?
CD dice game, yeah.
Bar dice maybe?
Oh, bar dice, sure, yeah. I named it something different online, but yeah, that's bar dice is fine.
Okay. And I don't know what we have inside. Should I look for it?
Well, just list it. List dash A. All right. Okay, so we have a REPL, and what you want to do is take a look at that REPL there. Vim bardice.repl. It's just to familiarize ourselves with what we did. I don't think we did very much. We did basically nothing. So the very first thing we have to do is clean up our keys here. So remember, keys are our cryptographic hashes that allow you to access modules if you have that password, basically. So it's like you're signing a transaction. That's all these keys do, and you basically need to get the right environmental data and environmental keys. And so could you go to the GitHub for us, please?
Sure.
Just show it on the screen. It's just fast. Now it's much faster because now I want you to go to dicegame.repo.
Okay.
And we're just going to just start grabbing things. So it's a little more commented here. And I want you to go to the top and grab everything down to hard-coded dice game.
Okay.
All right.
Here or?
Oh, don't forget the first part too.
Yep. Like this?
Yeah, just cut, just a right click, and copy, and then just go back into your Ubuntu. Good thing about Windows is there's a nice little.
Yes, it's fast.
Yeah.
And
so
now,
you can just so just press D a bunch of times,
okay,
and just erase it all. Yeah. Okay. Now paste that first bit.
To paste, can you remind me how to do it?
Right click.
Oh, just right click here is the same. Okay. I thought in Vim it was different.
There's a little trick here. Actually, press U to undo because we need to set the paste. I forgot. So escape, undo. Now press double dot or colon, as we like to say in America. So I'll just call it colon for now.
Colon, no worries. Yeah.
So just go colon and then go set, space, paste. Now press insert.
Oh, sorry.
Press insert. Now press right click. It's a little Vim trick for you to get everything nice. So press.
Oh, I need to go copy it again because I accidentally did a print screen. So
yeah, that's fine. That's fine.
Copy. And now
just grab that whole trick there. Perfect. Okay, so what we're doing here is there's this handy little trick called env exec config where that just gives us better error messaging. So I don't want to get too much into that. It just gives us better errors if we have them. We're setting up our environmental keys, the admin key. So very simple. And then we put the key into the environment. So your keys have to live in the environment, which is some sort of data store. I'm still trying to figure out what that is, but it just seems to me that if you want to swap keys back and forth between modules and the REPL, you need to load your keys up
to the environment.
Okay. Now, what is an environment? You know, God forbid, I don't know. I guess it's just, I'm just, you know, I always have these questions, and it just probably annoys Kadena team or anyone in Kadena because I'm just, you know, I want to know what things are. What is an environment? What do you mean by that? And so I guess what it means is that it's a special space where you can store references to things like keys. Yeah, you know what I mean? So it's Makes like sense. A special space. You might have a key value store, and that's where all your keys live. And the environment sort of protects it, like wraps around this data instead of just being everywhere and declared everywhere. So I guess that's what an environment is, but that's what's going on. Then we begin a transaction. So remember, REPLs are just transactions, right? So you load up your environmental data, and then you begin a transaction and you commit a transaction. And that's all a REPL is. It's just one after another. Begin transaction, commit transaction. That's the way to think about it. And that's just like a blockchain, right? A blockchain is just a bunch of functions where you can make an immutable transaction, you do it, you commit, and then the database is saved, right? Yep. So that's the idea behind here. And we're, as you see, we're loading 3 modules here.
I need to make sure that the dice game is the same in terms of name. I don't know if it's bar dice or dice game.
Yeah, you can just change that to bar dice really quick.
I think it's bar dice. Let me.
Yeah. Perfecto. Okay, and then what I want you to do is I want you to comment out the last 2 lines because we're going to go through this one at a time. So just go up to the last 2 loads. Sorry. No. Up to the loads. Comment the last 2 loads out. Oh, just one at a time.
How do I do that? Is this? No.
Semicolon, semicolon. Yeah. And then same. Okay, so we're going to focus on the top layer of the onion right now, which is defining players. Okay. So player.pact. So we already did that. So maybe you can just pop out of here. You can right quit
And WQ, right?
Yeah.
Okay. And now
Perfect.
we go to. Oh, it's actually it's dice game. Actually, we had it right. Sorry.
Well, we'll get down there.
Yeah. Let's go to player. Correct.
We'll figure it out. Yeah, go to player. Okay, and all we had here was this module where we were creating some stuff. So this is fairly simple. You have an administrative key. We actually defined that incorrectly. Now that I know keys pretty well, I didn't last week, but now I do. We're going to just mow this over and go and get the player. So we were doing the right thing here. So just to review this, we created a module. We had a key set. We passed in that key set. We were saying, it's probably the player's key set, but in this case, we just want the administrative key set, and we'll figure out why later. And then you have a module, you call it something, you load in that key set so you can access the table and functions inside that module. And then you have a schema, which is like the data you need. You're describing what a player is, right?
Okay. Yeah.
Then you define a table, you create the table. It's very simple. So that's what all that was. But let's now go into the GitHub, because now we have more code. And we don't want to write it all out and bore people to tears again.
Player, correct?
Yeah. This is just the pack. This is the module. Now I want you to grab the whole thing all the way down. So simple. Grab it.
Now delete all of this.
Yeah, just so you can D really fast. Just hold D down. It's pretty cheesy. There's other ways to do it in Vim which are fast, but if you just press D,
it's not working. It's deleting one thing at a time. I don't know why.
Oh, okay. Press. Shouldn't do that. Just press escape really quick. Now press DD.
Oh, okay, sorry. I was sorry, my bad. I was hitting delete. So my mistake. Okay.
It's actually not efficient in Vim to do that, but it's nice. It's a nice little trick while you're learning Vim to.
Yeah.
It's just DD.
Yeah.
YY for copy for yank and P for paste.
Okay.
It's always shortcuts. But now we can
paste.
Set paste.
Set paste.
Set paste.
Okay.
Yeah. Insert.
And let's right click. Oh, there we go.
Oh, thank you GitHub for your information. Let's erase that GitHub stuff.
Where?
That
here.
footer. I don't know what all that is. I guess we copied some of the GitHub's footer. Sure, just DD.
Oh.
Okay.
That's it. One more. Oh, it was one too many. Sorry.
Afonso.
Oh, undo, right? Undo.
Yeah. Escape. U. Go down one. You see, you're learning already. It's good. And R is redo, just in case.
Okay.
So go DD.
Okay, that's it. We're good.
Now we have a player's module here to look at. Great. So let's go through this whole thing. Up to the top you go. Press U. Undo. Use your undo. There you go. Now I think you can press home to go up to the top, actually.
Okay, yeah.
Which is nice.
Next time.
So here we go. So it's a little better commented this time. We have a player module. We require the administrative key set to use this module. We have a module, we call it player. So it's the same thing. We have an administrative key that pops in, and we'll deal with permissions next time. This is just getting everything running and running some functions, right? We're just talking about functions today and how to run them in the REPL. And then we'll get to like better stuff like auth and then kind of bite some of KDA's code, which is pretty good on their tutorials. Seem to have some spacing issues there.
Yeah.
That's okay.
It's my settings on Vim, I think.
Oh, brother. Oh, man, so bad. No, I'm just joking. So we have a def schema, and it's very simple. The player, the user, is just a name. That's like Afonso or Steven. And then we're completely defined by our key set, right? That's who we are in crypto world. So that's just bitten right from KDA main code, period.
Okay.
And so if you hear my cat meowing, it's just having a problem. But now we have the table, and of course it just loads that schema. inside the table.
Can I ask you a question here? Shouldn't we
Yes,
create a table? Oh, we created it on the bottom, right?
at the bottom, after the module, always
Okay.
after the module. So it's already done for you. And now the interesting thing is we're writing some functions here, and we want to explain this to people who, are new to Pact. People who are Pact wizards, this is child's play, but definitely we want to, and we can fix our spacing too. We have some functions here which are very basic. So we have this concept of creating a player, getting a player. I do not think you can delete a player in an immutable blockchain. So these are our two functions of interest.
Okay.
And then we have this thing called authentication, but we might do that next time because, I don't know if we'll have enough time to do all the authentication, but we'll get to it. So if you just want to go down a little bit, let's just go through all the functions. So, and then we have this function called enforce player auth, which we'll just leave there for next time, but we'll explain it while we're here.
Okay.
So very first function is very simple, right? It's a definition of a function. So whenever you're making a function, you use defun, right? So definition of function. And then we give it a name, which is get player. And then it's important to type, or, when people are reading your code, to type the thing that goes into this function. So a function takes input and gives you an output, right?
Correct.
Very simple, very simple. So in this case, we are giving an ID. So in the table, we have an ID, and that ID is probably going to be some kind of hash or something like that. For now, it's just a string. So, it's going to be some hash that describes you. And then what it is that hash then maps to the name and the key set, right? The schema. And that's all it is. And what we're doing is we're passing in an ID and we call it a string. We make sure we make it nice and legible for people. And then what we're doing is we're running this function called read.
Okay.
And what that does is it reads one line, one row.
So
players table
is a table, correct? Okay.
That's right. Now let's go to the Pact documentation and look at these two things, defun and read. So we're going to go through it very pedantically because this is how I learn. I suck at Pact right now, but I'm learning fast. And this is how I learn is I come here and I usually struggle with Kadena's definitions because they're very terse, very sparse. But when I figure it out and I come back and I read their definitions, it's exactly what I figured out. Yeah. So Kadena is usually always right. Just the examples are usually not enough, and so you just have to struggle a little bit. But that's why we're here, is to reduce the struggle.
It's hard to have a definition make you understand what it does, right? It's correct, the definition, but it's not. You don't understand at first how to use it
because it's abstracted into Haskell, right?
Of course.
And so we are some sort of weird hybrid of Haskell. So we don't really understand everything the first time. So, we always come here. I always come here to look at what I am doing. And this is how I learn the little things that they do. And this is a great place to be. So let's look at what defun is actually doing. So they say we're defining a name as a function. So that's the name of the function, obviously. We have an argument list, which is wrapped in brackets. And then maybe a line, which is like a string of documentation. And then the body, which can be a bunch of functions or expressions that happen inside the body. So body can be one or more. That's very important to understand. Okay, so we understand what a function is. That's pretty simple, right?
Funny that here arglist is not between brackets. Should be, right?
Well, an arglist is a bracketed expression.
Oh, okay. It's okay by default.
It's. I mean, we can really dig deep, but let's save time and let's save people's lives and just say an arglist is a bracket with some inputs. Okay. So the next thing we want to do is look at read, which is a database operation. So once we go through it once, we never have to do it again. So
let's see.
So read is some weird function that takes T and R as inputs. Okay, what is T and R? The value of a read before or after a transaction, supported in properties. So that's again an example of a very terse documentation with no example. So I don't know. I would fix that if I was there, but we can figure it out. And once we figure it out, we can come back. So that all works as well. So let's take a look at what T and R are up there. So T is A. what? In R, in R is
Is
a
a string.
string. Okay. It takes time, produces an object. Okay, so that's clear. Remember, an object was like a JSON, basically.
Hmm.
Remember last time we figured that out. Where A is of type table
Or string.
or string. Great. So it is all explained there. That's nice. So, I mean, I understand it, but when you're first looking at it, so you're basically putting a table or a string. So a table is when you have the single quote variable thingy. That's what a table is, right?
Mm.
And then you can either have a string as well. And so if we go back to read now, it should all make sense. It's always good to look at the definition. But now we can go back to the code. We never have to see read again. We're done with that. Of course, we defined a table, and that is the table.
Yeah.
So that is the table itself, or you can actually do a string if you like. But generally, I think the idiosyncratic way to do that, I think I got that word right, is to just type the table name, which is players. And then what we're doing is passing in a string. And of course, we defined ID as string. Boom. Okay. Now we can read any player, and it will return an object.
It's funny that as soon as I saw this, I understood what we're doing, right? We're reading from players and we're reading an ID. But if I look at the Pact thingy, the documentation, I had no idea what to make of it. So it's definitely easier to see it as an example. When you have examples, it's much better to understand what's going on.
Oh, I've coded for many years, many years, and I still had many troubles this week trying to figure everything out. And it's just a matter of you got to put the time in. Kadena can't do everything for you, right? So if you're learning how to code, you got to power up and get it done and play with this stuff and suffer with it a bit. So Wednesday was particularly bad for me in Pact World. But I learn a lot and I'm happy about that. So let's go down to create a game now then.
Okay.
And I want to explain what's going on here. So let's fix the spacing, if you please. Press insert. I'm a stickler for that. And then backspace. Just space it up. At the end of the tutorial, I'll fix your spacing for good. But for now, just use spacebar like a terrible vimmer.
Is this
again
good?
My chief? Yep, that's good. So here is the create player, and essentially what we want to do here is enforce a key set where. So first of all, it's a function called create player. We're taking in 3 arguments, and the arguments are ID, which is a string, the name, so Afonso Stephen, pretty much, and then we have a key set, which is a string, all right? And then what we do is we want to enforce the key set. So basically, we only wanted Min to be able to create players, but we're going to do that next time. But that's what that comment is going to be there for. So essentially, in the future, we're going to, so next time when we deal with authentication in part 3, authentication and pushing to testnet, that's going to be part 3. We're going to start doing these enforces where we control everything.
Who can have access to creating the things, right? The players.
Yeah, but if I included that all, it would go too far today because we got a lot to get through still. So
let's go step by step.
Step by step. So we'll leave that out in comment for now. What matters here is that we're inserting something into the players table with the ID as the key. And then the thing that we're entering is exactly the schema, right? That we defined. So the player is just a name and a key set.
Exactly.
So here's an interesting function here called read key set. So we have a string that we're passing in, and we're reading a key set from that. All right, and read key set turns a string into a key set.
Oh, okay. Got it.
Okay, so let's go look at that function now. So we're going to look at insert and read key set. So let's go have a look.
Insert?
So insert, this one's very fast. We don't have to spend much time here. It's much like read. Insert is just putting things into a table. It's,
right, entering the table for key.
So easy.
Yeah, this one is pretty straightforward, right?
Look at that great example too. That's perfect. So you have an insert, the table, the key, and then all the values. Done.
Done.
So the next thing we want to do though is look at read key set. See what the hell that is. So
here.
Kaboom, read key set. So what this is doing is it takes a string and it changes it into a key set item. Yeah. So it reads a key from message data as a key set. And then a predicate function is just a true or false. We don't need to get into that. That's another time. But basically, you're getting a key set out of this. So that's nice. And that's exactly what we want, because your key set is what defines you. And the key sets will be used for authorization in the next tutorial. So that's why we have this. The key set is you. Okay. And the name is just a nickname, right? You can change that anytime. But the key set is who you are in crypto world. So that's what we're doing. So we can go back to the code. So read key set's just string to key set. It's no big deal.
Nice and easy.
Takes your string and it pops you out key set, and then it inserts it into the DB. And now you actually exist in the table. So Afonso, you exist. This is amazing. This is amazing.
Yeah.
And then we got a function we're going to use next time. I just thought I thought I would get it all done, but we'll just take a look at it really quick. You might as well just go through it. So you want to enforce player authorization. So basically you need a function. Actually, you probably want to space that back.
Oh, sorry.
Forward. Yeah, that's right. You want to enforce player authorization. So what you can do is you can pop in. So there's this function called with read. So this one's really, we don't even need to look at it. It's so easy. So instead of read, you're doing something with the thing that you read.
Ah, okay. And this is the thing you're doing.
Exactly. So, I mean, it's so simple, right? So what we're doing is we're going in and what we're doing is with read, we are only looking at the key set value here.
Okay.
Okay. So I'm going into players by name. So I'm giving you a name. So it's going to be Afonso. And with that, I'm going to read that value and then only get the key set part of it.
Okay.
That's what it's saying there. Mm-hmm. And then we're going to enforce the key set. So let's go look at enforce key set and what that is. I know it's pretty pedantic, but we're going through everything. It's just good. Good to do that.
It's always better to understand what you're doing, right? And not just
do all day long. Yeah, it's all it is. Never ending. So cool. So here we're taking something called a guard.
Okay.
So a key set is actually a guard type. Okay. So what a guard is basically it makes sure that you can't fire a function. It guards a function from being fired unless a condition is met. That's how I understand it in Haskell. Okay. Now, maybe Kadena main core would not like that description, but that's how I understand it. And if anyone knows guards better than I, just tell me. But in Elm, which is based off Haskell, you can have which is basically Haskell. You have a function, and then you can guard it with a condition. So
okay.
Run this function if and only if this key set is here. That's the guard. So okay. It's like the if part of it, and you can kind of attach that to a function. So that's what a key set essentially is here, and you're enforcing the key set.
So that makes sense. It has a guard, and that the guard is what enforces the key set, right?
And you get a Boolean, which is true or false, right? So depending on predicate logic, so predicate logic is those functions there. So keys any, match at least one key in a key set. So you might have 50 players, 50 keys. You can only run this function if you have at least one match in the 50 keys.
Okay.
Or you might have a function that drains everyone's wallet and sends it to Steven. And so I need keys all for that. Right?
Let's not do that one. Let's not do that one. Maybe.
I know we're not on Ethereum and Solana, so we don't like that function.
We don't like
That's Ethereum and Solana type function there. So keys all is you need to match all of the keys. So 50 keys, maybe you have a function that needs all 50 keys to match, like gift all players one token. That's a good function. That's a Kadena function. Gift all players one token. That's great. Everyone likes that. And then we have keys 2, which is meant for transactions. Okay, so just going through predicate logic. So keys 2 is, you might feed in that logic. You might say that key set needs to run this logic, and that's more for two-person transactions between wallets, right?
Makes sense.
So to run this wallet function, Afonso better be here with his key set. Stephen better be here with his key set. Otherwise, no transaction can take place. So they're just guards which block bad key sets from doing bad things in modules. That's all. And so when we use enforce key set, that's all we're really doing. And so if we go back to the code, it's very simple. All we're doing is saying, look, if this person is Afonso and I give you the name, now make sure that this person is enforcing that logic. So if I get your key from you, you give me a name and I get your key, we're just going to enforce the rules that belong to that key set. That's all.
Okay.
And we're going to deal with that next tutorial, but I just wanted to explain what that function is. Basically.
Yeah, since it's here, it makes sense.
And now we're done. So we can get out of this. We just have create player, get player, basically. And that's all we really care about now, and a nice table. So what we can do is we can go back to the GitHub. Now we're going to go into the REPL and get the creation of the players part now. We can actually do something, which is cool.
Okay. So we'll go to the REPL.
Nope. Yeah, REPL. That's right. So look at this. We have add dice game players to the table. Here. Great. So what we're going to do is we're going to grab that first chunk, that first transaction. So grab the comment to hard-coded dice game. Okay. Always good to be, it just looks nice, right? Comment like that.
Should we go until this here?
Yeah, to that, right. One transaction at a time. Right? That's all REPLs are. It's just a begin, commit, begin, commit. That's all REPLs are, really. Some environmental data, some loads. So simple, right?
We go to bar dice REPL again.
Your REPL, that's right. Now you can go down, set paste, insert, and paste it below your loads. Make sure you go down. You can press end.
I should have, but now I didn't.
Very, very naughty. That's okay. You'll learn in time. Vim comes slowly. And so great. So we have some great code here. Some spacing issues.
As usual.
It's because of the tab. It's so annoying. So
should I?
No, let's. Yeah, space it up. It's just
like this.
Sorry about that. Yeah, I don't know why it's doing that.
Is this the way it's supposed to be indented?
No,
like
two back. So that line 24, two back, and then move that forward to Stephen Key, so it's all lines up nicely. Yeah, that's how it should look. Okay. See, isn't that nice?
That's better.
And then your defines move back. We'll explain all this in a second, and then we'll run it. And we'll, can we actually create people? Mm-hmm. Yes, we can. So, and space that back. Okay, so we're going to explain what the heck's going on here. So we have, we start our dice game. Now we're starting to do something. Mm-hmm. We begin a transaction. Obviously, it's a REPL, so everything is transactional. And what we're doing now is we are building our keys for the individual players themselves. So we have an admin key before, right? Mm-hmm. Which is the administrator of the application.
Whoever is right.
But now yeah, that's right. And now we need to make keys for Afonso and Stephen, who are players. So we can do things and the administrator can do things. Okay. But for us, when we're clicking this button, it's our keys that need to go into the create player function. So what we do is we use this cool function called environmental signatures, because we're signing off on transactions eventually, right?
Yeah.
And so what we do is we use this little function called env-sigs, and it takes a list and it takes these objects of a key and the key's capabilities. And
which
the key
empty.
Yeah, we don't need to get into that until next time.
Okay.
But this is just the general. This is like the hello world of signing key signatures, I
Okay.
guess.
Okay.
We can get into capabilities next time.
Yeah.
Otherwise, it would be a two-hour journey. So
Okay.
in this case, what we're doing is just setting up the signatures for these keys so that we can sign on transactions and no capabilities.
Okay.
It's
Let me
just
let me just. This is what we need to do. Like in the when we have a real UI with a like a wallet connected. This is the part where it just pops up so we can sign the transaction. Correct? Am I crazy? No. This is the
even to read a key set into the create player function, we need to do this.
okay.
We need to get keys out of this because remember the when we're creating the player, we need to send in a string,
Yeah.
and that string has to be a message which can be turned into a key set.
Okay. So it needs to be our keys already. Yeah.
Why don't we go look at the function? I mean, we should look
Okay.
at every function we do. So
And
env sigs
v6.
every time. You know, I'm not an expert yet. I'm still figuring everything out, and actually got the good guys from Mock to help me out because keys were so badly documented. This part I don't like the document, and you know what? I'm going to say my truth. And there's some parts which are very well documented, like database functions, superb. But then there's the key sets, and it's just hard to understand how it all works together when you're first. Imagine if you don't know much about code, you're trying to figure it out. It's a nightmare. So
Yeah.
these types of journeys that we're taking, I think, will help people.
Yeah.
And
I hope so.
let's look at the definition. We're setting a transaction signature, keys, and capabilities. So it's a list of objects with a key, specifying the signer key, and caps specifying a list of capabilities. So you're just telling the environment, you're specifying what the signer keys are. So Afonso and Steven want to sign transactions. Here are their keys. And if they got special capabilities, like,
what they can do, right? And this is like what they can do. Okay.
yeah, and we'll get into that next time. That's going to be a different journey, but
Yeah.
that's all it is. It's just you're saying these are the people who can do stuff in dice games. So generally, you would have a bunch of players and you would store all of their signatures, and then they can join games at will and gamble and stuff like that. So let's go back to the code. Now we already know what environmental data is. That's pretty easy. We have already done that, and we're just loading up Steven key and Afonso key.
Correct.
So very simple. So now it's in the environment now. The data is in the environment, so we can actually see it now. And then what we're going to do is we're going to define key set now. All right. And what we do is now that it's in the environment, we can just pull down Steven key and Afonso key.
Okay.
And what we're going to do is we're going to read the key set. So remember what a read key set does. Changes a string
into a key set.
into a key set, which is a guard.
It's starting it here, right? In Steven key and Afonso key.
Yeah, that's right. I mean, we can look. Let's go look at define key set. We haven't looked at that yet.
Sure.
Once again, we just walk through everything, like just so diligent. So let's go see what this is.
Define key set.
I mean, it's just defining the key set, but might as well look, right? I mean, it's pretty obvious what's going on here. But so define a key set as a name with a key set. If unspecified, read name from message payload as a key set. Okay. If key set name already exists, key set will be enforced before updating to new value. So I don't even know what that means. That's a frustrating. I think that would be very frustrating for somebody who is not Cadena core team to read, because they understand it intimately. But maybe we can get something from the definition. So above it says we're taking a name, which is a string, and a key set going from a string to a string. I see. So it's probably just taking a string and then forming it up into the right message, so the right structure.
Okay.
Okay.
And it says that if a name already exists, it will be enforced. I don't know what this means.
If the name already exists, key set will be enforced. So key set's like a guard, okay? Like it's important to understand that. It's a guard type, I believe. So you're enforcing the guard before updating to a new value. All right, I'm not going to pretend I totally understand that at all. Like, I don't feel like I'm stupid, but I think the language should be very, very simple here. And so I guess kind of, obviously we're just defining a key set. So I guess it's just creating a structure. So you're reading in the key set and you're getting like this nice structure out of it, which is just a string in the end of the day.
Okay.
So it's probably just preparing a message for doing things like enforcing key sets, you see.
I think we got the gist of it.
Yeah, okay. Let's go back to the code. I'm going to say I understand that about half. But I know you need to do it. You need to define a key set.
Okay.
And then here's where the magic happens. So there's this nice function called use. And use opens up functions in the module that we loaded up, which is player. So in the REPL, we need to use the create player function. So in this transaction, we can say, look, I want to use the functions in player module.
Okay.
And lo and behold, we created a player, didn't we?
ID 1, Steven.
That's it. So that should make exactly what we need. So let's get out of here.
Okay.
And I'm going to stay a little longer. You got a little longer today, maybe? We can.
Sure.
Okay. I want to get it all in.
Yeah, man.
So now we can actually do stuff. So let's see if this all works. Pact. And then in brackets.
Always.
Load. bardice.repl. Should run that program. What? Oh, in quotes.
Oh, sorry.
It's my bad.
Here?
Yes.
Okay.
Let's go. Well, hallelujah, it actually worked.
Wow.
We actually did something. So, but now we should check our table and see if that, remember it's ID1 and ID2. That's what our little IDs are. That's what defines me and you, right?
How do we access the table?
Well, we're going to run our function called getPlayer, right? So let's run a function. And I believe that we have everything loaded already. So getPlayer is fine. Get dash player. And the input is simply a string.
ID1?
I think so, yeah.
No.
Okay, so player.getPlayer. Try that.
How?
Put a player dot in front of getPlayer.
Oh.
No.
GetPlayer?
In front. No.
Sorry.
In front of get, sorry. It's my English.
Get.player. Okay, sorry.
Player.getPlayer. No. Dash. Return the dash.
That's why we're pre-coding it.
In front of get. In front of get.
In front of get here?
What, 2 over more? No, as behind get, I guess. Sorry.
Okay.
Yeah, we're dyslexic here. Yeah, you're behind. I am. Yeah. Okay. So
player.getPlayer. Okay.
Yes.
Oh, we're accessing this. Okay, makes sense. Player.getPlayer like this.
Try that.
There we go.
So in fact, we have a key set with a key set type. Isn't that nice?
Nice.
And there you are. This is you and this is me, and we exist in the table immutably for all time. That is until we get out of Pact, because it's not a deployed smart contract. So, but we exist, and that's nice to exist. I think, therefore, I am. Rene Descartes. I'm happy to exist. Yeah. I doubt too.
That's
so,
good. So we actually did something in Pact now, right? We created a couple of players for our Bardice game, ourselves in this case.
And we can get the players and see that we actually can do that. So we can run these functions anytime we want. But let's move on now to the actual creation of the game. So We've got another 40 minutes, so I would like to get at least the game going and rolling some dice, and then that would be wonderful.
Let's do
So
it.
let's Command D out of this, Control D to quit.
Good.
Okay, now what we want to do is go back to the REPL. Yes, now let's load up bardice.pact. Or sorry, uncomment, not load up.
It's not Paradise. Okay, let me.
Dice game, yeah.
Yeah, you had it right the first time. Where am I? Oh, in there.
Now that we've seen a lot of things, we can go faster even. So.
And it's.
Wish I could upload code into my mind. That would be great.
Okay. Can we get out of the REPL now?
Yes.
Okay.
Yes. Now we're going to go to dicegame.pact. We're going to toast everything and go and get the other.
Here? Right now?
Yeah.
Okay.
Now remember, in dice game we were expressing this object, which is a room, so we don't have to go through everything again. But just describing the schema is all we really need to do. It was a room, and the room is a string, so it could be like Afonso's dice bar, or pit of hell, or whatever you want to call your room. And then you have the players, which belong to that game. So it's me and you that belong to that game, and you need to know who's playing the game, right?
Of course.
And then a maximum number of rounds, which is 3. 3 is traditional ship captain crew bar dice. And then what is the current round?
Yep.
Has the game started? Yes or no?
Mm-hmm.
And then the actual throws in the game. But I've actually changed this as I decided different logics. So what I want to do is not too much, just one thing, but press V. I'll show you how to do this. Just press V. Mm-hmm. Then go all the way down to the bottom.
And?
Shift down.
Okay.
And then right a bit, shift right. And now press DD. Boom, so fast. See, Vim tricks, man, you're learning. This is amazing. Let's go. I love Vim. It's the best. I don't know why people use SDKs. I use Vim. So let's go now to dicegame.pact.
There we go.
Okay, a bunch of stuff exists here, so let's grab it all.
Whoa, this is big.
Why did GitHub space all my stuff? GitHub. It's so irritating.
And now
set paste. You know the game. I don't need to say it no more. You're Vim master now.
Yeah.
My CTO will call you. He'll give you a gift. He'll give you some of his homemade beer now. So, so let's go up to
home. I can't go home. Why? Wait.
What is it? Shift A. I forget what. Actually, this is a good trick to teach people how to get to the top of the page. One sec. I got my Internet Explorer here. Vim top of page command. GG.
GG?
Yeah.
Oh, there we go. Good game.
GG. Yeah, I love GG. Yeah. Good game. I don't want to code anymore. GG, bye. But here we are. So it's so easy. There's another trick for you guys in Vim. GG. So same thing. I mean, we don't need to go through all this stuff that is obvious. We can go down to the schema. And you're going to see I took out throws here. And I did that for a reason. We'll find out later. Because it's like layers of an onion when you're building smart contract. Okay, so players exist above the game, and in the game is the actions that happen. So we don't want to save the actions in the game object because each layer of the onion has to call upwards. So there's a natural waterfall of functions that happen here, and we'll figure out what that all means. So let's space the definition a little bit, just because it bugs the hell out of me. Like this? Okay, great. And so look, we took out throws, but we now have a new Boolean called has ended. So has the game started, has the game ended, okay?
Yeah, because at some point it hasn't started and it hasn't And it hasn't ended. Okay. And you need both to know in which phase you are, right? Know at which point you
Yeah,
are. Mm-hmm.
and we'll see why we need that later. Again, we have the room. The players are just player schemas, key sets, and names, just objects, and it's a big list of those guys. That's what square brackets means. Num rounds and then the round. So it's super easy. Now we get into the functions, which is the stuff that we really care about.
Yeah.
Again, it's only accessible by the administrative key for now. So here, like, we don't want players starting games. That would suck. So again, we just have simple functions. So get game. We already know what read does, so we can go and get the game, and it'll spit out the object.
Mm-hmm.
We have.
Oh, this is awful.
So let's.
Like this.
So nice. It's like my OCD is being satisfied. It's so good. So all that is has the game started. You give it a room. With the read, it goes and gets the Boolean, and then you just spit out the Boolean. It's true or false. That's all it is.
Okay.
So simple. Now we get players, of course. It's no different. All we're doing is we're saying, look, with the thing that I'm reading, I'm in that room. I just go and get the players, and then just please give me the list of players. That's all.
Okay.
So easy, right?
Yeah,
so all these little functions are
pretty straightforward. Yeah.
Yeah, so fast now because we already know what's going on. So here's just get the round. It's just an integer, but it's all important to have these little functions. It's our API. So downwards we go. Now we get into our first bit of complexity here.
Okay, this is more.
Right. So
more
now,
complex. Okay.
So now what's going on is we have to register the players in the game. So the players all exist immutably in the player table. They're sitting there just waiting to do stuff. There's nothing to do, so we got to give them something to do. So the first thing we can do is we can put them in a game and say, hey, you're here. It's like sitting at a table in poker. So we have a definition of a function, register players. We give it a room and we give it a list of players. It's super simple. Now we have this kind of neat thing called let. And what let does, so in Haskell, so there's a mysterious person on the KDABet builders Telegram. She is very mysterious, and we do not know who she is. She's anonymous, but she seems to know a lot about Haskell, quite a lot, and taught me something today about this function called let and why we use it. So what let does is it lets you define things and keep functions inside of the body pure. Now, what does that mean? So in Haskell, pure functions are functions that always give you the same output when given the same input. It's called a dempotency. That's what the word is for that. So x plus 2. If x is 2, 2 plus 2 always gives 4, right? That's an idempotent function. That's pure function. And it doesn't change the state of anything. And the state here is the database, okay? That's what a pure function is. Now, when you have an input, like calling a database, so for what we need here, we need to have this rule, and you see that enforce part there? You see that function called enforce? Now, what enforce needs to do is it needs to check if the game has started. And if the game has started, we're not going to do anything with this function, because if the game is started, the players are registered, period, right?
Of course.
Therefore, we're not adding new players in the middle of a game. We cannot do that. So we have to check if indeed this condition is true. So has it started? Is has started equal to false? And if not, we're going to tell the user the game in the room has already started. You cannot add any more players. You cannot register any more players to this game. However, if we called this function called has starters inside the enforce, what would happen?
If we had
what? So you see, so go down to enforce. Okay, now go to the right. See that little bracket right there? What is this saying? Has started had better be equal to false.
Okay.
Otherwise, I'm not.
Can I just, because I think it's too much information. This HS, you define it here.
That's right.
Okay.
And what HS is just this function called has started. with the input room. Remember, we already defined this above.
Okay. And you call it HS here. Okay.
Yeah, that's all. You're just defining things. Now, if you see that HS has started room thing that you were just at, and you plugged it in right there, Pact would kill you. It would say, no, you can't do this, because what you're doing is you're making a pure function impure, because at any given time in between these calls, you can change it to true or false, right?
Oh, okay. And that's what lets you do that.
That's right. So let's go to the definition of let and figure out what's going on. So we thank our anonymous Haskell friend. She's very anonymous, and we don't know who she is, but she's very smart on the Telegram builders.
And you know it,
builders.
and it's a woman. You know that at least.
My instinct tells me
that
is the case.
Okay.
It's just, I'm a man, right? I know.
I know. You have this sixth sense.
Yes, I like to, or my wife would say, I like to think I know. I probably don't. That's probably the case. But now let's go to let. So let's figure out what they're trying to say here. So there's this thing called a bind pair. Okay. Bind variables in a bind pair to be used in the scope over the body, which is just the functions, right? Enforce, do something, body of functions. Right, so there's a bunch of expressions, so the enforce is an expression.
Sorry, there's two lets. I'm just going up because there's two.
Oh, go to the first one. Yeah.
Sorry, yeah.
So look at that example. They give you, this is good. So good job, Kirena. Now, this is a good example. So look at what is going on. So it's let, and then you see the x2, y5. Those are the binded pairs. I am binding x to 2 and y to 5.
Okay.
And then the body, which is the expressions that I want to play around with, it's x times y. 2 times 5 is what? 10.
10.
Boom. That's all that is. You're just defining a bunch of variables so that, you can get around these pure function rules. That's what's going on, I guess, under the hood in Pact. Okay. So, when you have these problems where you might have a lot of unsafe things going on, remember, Pact is very safe language. Does not allow you to use these unbound variables as inputs. I think that's a good way to say that. Unbounded variables, that means the variables can change around and do a bunch of things in between calls. No. When you have these problems where you have to have the idempotent function, the function has to always return the same thing with the inputs, that's when you use the let function.
Okay.
All right. So that takes a little while to sink in, I think. It took me about a half a day to kind of just let that sink in. But let's go back to the code now. And now it just makes a lot of sense, right? It's like super. So, I can define all these things, which are stateful data, which can change around. But when I'm running this function now, bam, I can go and get all that data right now. Boom.
Okay.
And now that data is immutable and it sits there. And now I can use it further in functions in the body.
Makes sense.
Okay. I know that's a bit much for viewers, but listen to that a few times and you'll see. It comes naturally. So now we have the enforce. So we're basically saying, like, look, don't add any players unless unless the game hasn't started yet. That's great. So let's go look at the enforce function now. I think that's good to do. We still got a good time here.
Yeah.
Still got a good time. We'll get to dice rolls and then we'll call it a day, but that's good progress already compared to last time. It's much faster. So
yeah.
So here we have enforce, fail transaction with a message. If the pure expression, you see that definition there? Pure expression.
Yeah.
That's what we were talking about. If the pure expression is false, otherwise return true. So, hey, look, man, don't let this transaction go forward if the expression is false. It's so simple. That's all. So you're enforcing something. So you're enforcing logic before you fire the actual function, which keeps Pact nice and safe. Very nice. So let's go back. Now we know what enforce is. We never have to go back. We're going to see many, many enforces as we build this out. It's everywhere.
So
the next one,
if HS is false, it just gives you this message, correct? So if the game has started, okay, that makes a lot of sense. Okay.
Right, it just all clicks now, right? So The next thing is, should a room had better exist, right?
It should.
I think that's a good idea to ensure a room has to exist. I don't know if it's needed or not. It seemed to me to be needed, so I just threw it in there. So maybe just space it back too. I'm sorry that GitHub did that.
This one or wait,
yeah, it should all line up nicely. Oh, press U. You can press U to undo. Use your trick. Escape U.
Yeah.
Boom. Insert.
Okay. And this needs to go forward.
Just line it up with the previous comment. It doesn't need to space for it. See, room has to exist. Line it all up with that. Remember, it's the body. These are the function. You can press U. So, or like R for redo. Yeah. And then line it all up.
And this one as well.
Yeah, and then we'll fix your spacing right at the end because it's annoying.
This one is with let.
Should space 2. Every tab should be 2. 2, 2, 2, 2, 2. Okay, great. So the room has to exist, so we don't need to go over enforce again. But now we have this kind of neat thing called contains. So what we're saying is, look, in the entire database rooms, in the let variable called rooms, and rooms is just the keys of the games table. So remember, tables are, so we did this last tutorial, it's keys and values, key and value, key and value. And every dice game being played has this thing called a room. The room is the string which describes where the people are playing. It's like the table 1, table 2, table 3.
Okay.
And what we're saying is now is contains, so we don't need to look at contains. It's very easy. So what contains does is it goes into a list called rooms, and it's a list of all the games. It's the keys. And we're checking if our room is in
rooms,
that list.
Okay.
And if it's false, what does it do?
It gives you this message. It returns the game room, does not exist.
Yeah, and the format just is a nice way of having a dynamic string. So it chucks that room into that bracket there.
Because you put it here, right?
Yeah, and so format is exactly that. So you can have many brackets like that, and then you can have room,
player, game,
player, blah, 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 and it all just sticks it into the string in order, you see.
Okay, makes sense.
Right, so that's all that is. I mean, you can look at those functions yourself, but they're very simple. And so we don't need to expend time on that. Now here we have the update function. So this in Pact, you can update something that exists in the database table. Okay. So this is a state change, okay? Or at least I think of it that way. So I'm going to update in the games table a room, and I'm going to say the players is now going to go from an empty list, which is what we defined it to be. And we're going to now do this thing called a map. So a map is an operation that happens over a list. So if you have a list, 1, 2, 3, and you go map, add 1, it will be 2, 3, 4. Okay. So map goes through every object and does something to every element in that object.
Kind of a for loop, right? It just goes through each one of them and does something?
Not a for loop, a map over a list. So what it's doing, it's a limited recursion, I believe. So let's actually go look at it. Map's an important function. So when you're dealing with a list, sometimes you got to do something to everything in the list, right? So you're bringing map to it, and then you're transforming that list data into a new list. So it's list to list. List to list. That's all it is. So apply some function to each element in a list.
By F to each element. Okay. Okay, applies a function to each element. Makes sense. Okay.
Yep. Now we go back. Now it all makes sense. It all clicks. Yep. Legion. It's the e-gaming. So all we're doing is, so for each player in the players list, we are just using our get player function that we had before, right? Remember, it just took an ID and then it gave us the key set and the name.
Yeah, we did this already on the command line. So what it's doing, it's going to the room and get player for each player in the room. That's it.
And then it appends it to the immutable table, right? It appends it. So these are the players that exist in this game. Okay. Done. You're now seated at the table. let's go down. So let's fire through these functions so that we can run the cool part. Okay, so the next one is create a game.
Let's try this. Okay.
Beautiful.
Create
Back
a
to.
game. We need to tell them the room. Okay.
Yeah, you walk me through this. What's going on?
Okay, so this is easy. This is the input. You need to input the room that the game is going on in, right?
Yeah, just the string. Right?
And then insert. So you're putting
a new game.
You're putting the room inside the games table, right?
That's right. And then you give it the actual values.
Oh, you give it okay. You give it as ended false, of course. It started false. Oh, so we haven't started yet. We're just updating, right? We're just creating it.
Creating it, yeah. And then you got the room, number of rounds.
And the round is 0 because it's the first one, of course.
There's no players yet, so.
There's no players yet, but shouldn't there be the players? Shouldn't the players already be in the room?
No. You're creating a game with players who will join the room. That's what register players is. Okay. So they join the room, right?
Mm-hmm. Oh, okay.
So now we have the starting of the game. Again, we have let because we have an enforce, so we want to keep our functions pure.
Mm-hmm. Let players get players room. Okay. Let me just put this the way you like it.
So now you have this thing that's just a list of players. That's all it is. So you have this thing called players, which is a list of players. And okay. Hey, man, there better be at least greater or equal than 2 players. Otherwise, you're playing by yourself.
Solo.
You're taking your own money off of you. Or maybe nobody's playing against each other. And then the house is like not making any money. So that's not good for business. So we want at least 2 players to be in the room. It's so simple.
Yeah.
And then when 2 players are in the room, and there's nobody else left to join, we can start the game.
Okay, you started to run. Okay, makes sense.
Round 1, right? So simple. So we update the.
Okay.
Okay, now we go down. Now we have this thing called advance the game. Now, we're going to have this function later to advance the round.
Oh.
There's 3 rounds in a game of dice. You throw the dice 3 times, then you end the game. And we're going to have this function later on, and you'll see why. But let's define it now. We're just advancing the game. You give it a room. You give it the current round, which is 1. If this... Yeah, go ahead.
Yeah, it seems pretty easy. You just add 1 to the current round, right? You just add.
That's right. That's all it is. And then let's go to the last function. Okay, I just had some stuff I was working on here, just playing around the other day, and we'll come back.
This one, it's all commented, right?
Oh, yeah, I guess I cut and paste some stuff. I was planning on doing something, and I commented it out, but the only line that matters is that one.
And
for now. So go down. And down you go.
Should I? Oh, I shouldn't uncomment anything?
Nope.
Okay.
I was up to something and didn't clean it up. Just didn't have, because my computer crashed as I got the green screen of death 30 minutes before this YouTube, so I didn't get to clean it up. So let's now just space everything nicely, and then we're out of this module. We're completely done. We're almost done.
Okay. This all should be indented, right?
Yeah, and the way you can do that actually no, because your spacing screwed up, so you don't want to do that. Just indent it 2 forward.
This one, right?
That's right. Done.
Okay.
We'll fix it later. And then that guy at the bottom, the very bottom one, is indented too much. Go up to 94. Yeah, there you go. One more.
Yeah.
Done deal.
Okay, right.
Now we're done. So we have all the functions we need to start, end, and advance games, create a game, and add players to the game. We're done. So we create the table. Now we can go to...
the REPL?
Yeah, we can go to REPL, open it up. Now we're going to go to the GitHub and we're going to grab the next transaction.
Okay.
Now here's cool because we're actually like embedding. So we're using the players module and embedding a function into. It's kind of cool, right? So it's a cross-module communication.
Yeah,
right?
yeah, yeah.
So
yeah.
players is at the top. Now games is at the bottom.
We
Is
use
inside
players
the
in the
onion.
game. Mhm.
Use players in the game
And
using
now
a player schema in the game itself.
play
So
a hardcore dice game, right?
hard-coded. So
Hardcoded.
actually
And it's going to
grab
be
the one
hardcore as
above
well.
it. Grab the one above
Oh,
it.
start. Okay, okay, sorry.
And we're going to start the game, right? You have to
Just-
start the game.
Just this one, right?
That's right.
And now
Now you put it next in the REPL. I think this is going to be the last bit we get to. It's almost an hour now. I have Mata in 10 minutes. State of the Union update. So we'll at least get to see everything started up. And then maybe we can, now that we have this system and things are getting coded up, we can do more frequent.
and does it work, by the way?
P for paste?
No.
Or
P?
escape P? Hey, look at that.
But
Wait, go down? What did you do?
I pasted something that's not what's...
Oh, okay. Just
Undo?
press undo then. Escape, undo. See, undo is so beautiful. Maybe you just have to right click copy, yeah. And then
P?
right click. Just press right click. Windows is a little weird.
What? No.
Press undo.
Undo? Oh no.
Escape, undo. Now go underneath commit TX. So give it a few returns.
And now right
And I'll
click?
see what happens. Yeah.
Okay, that's good.
I don't know what the hell. I don't know.
Doesn't matter. We got it done.
Okay, but so we're at least going to get some more stuff done here. We're going to actually start a game, and then I think that's about as far as we get. But we can do this a lot more now because things are really rolling. So I like this. This is much better than before. It's faster.
Yeah.
So
And we can go through the thought process that I can tell you what I understand of what's going on, and you can just say, no, that's not exactly what's going on. It's more like this, and so we can move forward faster, I think, than me just typing. Makes sense.
So usually this is done in API, right? Like, you would have an API, like you wouldn't actually hard code these transactions into a smart contract. So, but in the REPL, we can simulate what is happening transaction by transaction, right? That's what's really going on in the REPL here. So we're beginning a transaction, and we have this nice function called use again, which allows us to use the functions inside Bardice. I think we called it
Dice game?
Bardice. I don't know. I don't know. No, I think I called it Bardice actually. We can go check. Just WQ out of this really quick. Right, quit. Let's just make sure. What the hell? Or WQ, not WP.
Okay.
Print it out. Do you have a printer? Go to just Dice Game Pact. See what we called it. Bardice is what we called it. So it's correct.
Bardice.
I did actually code it correctly. That's good. Okay. So go back to the REPL. Yeah, shit naming, but that's the way it is. So we go down to the bottom now. So we've added all our players. That's great. Down.
Right.
And, what is it? GG and...
GG is for the top, right?
Yeah, forget the bottom. You know what? I'm gonna do it because I can't stand it.
It should be easy. Easy. GG, easy. That's what I always write in the end of my games. So
Shift G.
Shift G. Okay. Let's see. Yeah, that's fine. That's right.
Good.
That works.
It's tricks. It's fast. When you use Vim, it's much faster than SDKs, like 10 times faster when you get good at it. But it's been so long, so used to my little SDKs and environmental, different environments like Java and stuff. Okay, just trying to get back on the pod here. Okay, there we go. So now let's just look at what we're doing here. So we're creating a game called Dive Bar. So, Afonso's Dive Bar, basically.
Okay.
That's going to be the administrators.
This is the name of the game, right?
The
Just
name of
that.
the game, right? That's the room.
Mm-hmm.
Now we're going to add players to the game. And the players we're going to add are ID1 and
Ourselves.
ID2.
Yeah.
All right. So we should probably have a check in there to make sure that you cannot add ID 50, but we haven't got that far yet. I'll fix that for next time.
Okay.
So you see, if we had ID 50, that would suck, right? Because ID 50 doesn't even
It
exist.
does
But
exist, exactly.
just didn't get that far. But for now, we just want to run these functions and see if they work. So we can register the players.
Okay.
Then we can start the game. And then we can test if the game exists after. So let's just save.
Okay.
So right quit. Let's just run the REPL. So Pact. Press up one. Up a couple times till we get to the load. There we go. Run it. Kaboom.
Did we start the game?
We did.
Right. Yeah, we did. Yeah, we did.
But now we can go back, so we can quit out of this. So that worked. That's good. We can quit out of this. Now go to the REPL. Down you go. How do you do it? Shift what?
Shift G.
Boom. So see,
Damn.
efficiency, speed. You're like the Flash. It's amazing. See, Vim is amazing. Okay, so now we have that little commented bit out there that I did for you. Get game dive bar. Okay, well, we should uncomment that because we have a function called get game. It's very useful. Now we can actually see if it exists and the players have been added to the game.
Let's see.
So let's do that. Pact.
Let's
load.
go.
Look at that. Isn't that beautiful?
Num rounds 3 as ended false. It started true. Num rounds 3 players. We are all there. Round 1.
Everything works.
Nice.
Round 1. Fight. So everything is done. It's aging myself, Street Fighter. But so you see everything has worked properly. And so now you're seeing the natural flow and construction of a program that sits in a smart contract using Pact. So I did want to get dice rolls done, but have been over an hour now. So I think people are probably very tired and they've learned a lot with us today. And I think we have enough material to do 2.99 maybe, like really soon.
Yeah, sure. Let's do middle of this week if you can, and you have the time. In the meantime, I think the strategy for anyone who's watching in the future is just keep coming back, because this is not a thing that you can consume on one go and know it all. I speak for myself that I understood everything we did, but I can't remember it all. So if now you want to start doing like some kind of project in Pact, just keep coming back to this video, to the first one, and keep grinding. I will share the
GitHub link, yeah,
that we have here, so that you guys can use it as well.
So you see what we're doing is we're developing our intuition here. And okay, so REPLs are just series of transactions and loads and environmental data. And these modules are just schemas with functions. And as long as we understand all these little tricks, we can write functions and then run them.
Yeah,
and things happen.
And understanding what use does and what all those functions that we used are good for this, and people need to start interiorizing this and understanding how to process each of the steps. But I think we're doing good process, and I think it's much clearer how to do things now. For me, at least, it is.
Yeah, we were faster this time, and then next time we'll be even faster because we already know the functions. As long as you come back and relearn them, Afonso, then we'll know.
Man, I gotta do my homework for the next one.
Yeah, but just always make sure you remember what we learned, and then
of course.
So next time, let's just set up for next time, and then we'll call it a day. So next time, what we're going to do is we're going to finish off the rolling of the dice, the adding up of the points, the ending of the game. We're going to connect the wallet in, because now we have the players and the keys. We can get the wallets, the accounts, so we can steal all that nice code from Will Martino and Stuart Popejoy themselves, because they did wonderful tutorials on that. And then when we have all that together, we can end the game, transfer the money between each other, and then the very last thing we'll finish next time is the authorization checks that we alluded to today. Right? So this person can run this function. This person can run this function. And so we alluded to that, but we didn't quite get to it. The next time we will reveal that all, and then we will be ready to push to testnet and then start building an application.
Exactly, exactly. Lovely. I think it's going to get even more interesting next time. Folks, thanks for joining, whoever did and whoever is joining in the future and watching this after the fact. Thanks, and let's do it again really soon, Steven.
Thanks, Afonso.
See you guys.
Bye bye.